Okay, so welcome to Ham Radio, and this is going to be week 4. We're going to be covering Chapter 5, Operating Station Equipment. Okay, and we have lovely decorations because Valentine's Day is coming soon. So, this one is going to be kind of a fun one for me to teach because it's a little bit easier than all the math and electronic components, so you might enjoy this section a little bit more than the last one. So they have a picture of some radio station equipment here. You know, this is like, I would say overkill, but you know, if you get into it and you really enjoy it, you might want to set up some kind of station like that. I'm going to be using a few visual aids today. So the first one is handheld. This is also known as an HTX, handheld transmitter, TX for transmitter. Sometimes they'll say this is my HT. People will refer to that. So I want to teach you some of the jargon that you might hear over the air. And we're going to go over what some of these buttons are on here, part of the controls and what they're for. This particular one is the Yaesu FTD70. You notice it says digital on there. The D in the model stands for digital because it can actually transmit digital voice. And I've had this radio for like, I don't know, 6 months or a year, and I just figured out how to do it last week. Like, oh, it actually does digital voice. Kind of like the old days when cell phones first came out, it was analog, and you might hear like a little static in there. And then when they went to digital, it was like, can you hear me now? And you drop packets, but still is clear. The audio is better. Well, the same thing applies with this. You can do an AM or FM mode. We're going to be going over the different modes of transmission, but you can also do a digital mode. And you can do direct simplex, meaning straight from one radio to the other, with digital with this particular radio. There's also, we're going to be covering some digital modes. One of them that's popular is D-Star, and it is through, some of these are manufacturer specific, so like the Yaesu one has digital video protocol that they kind of created. They call it Fusion, I think. And so the problem is if you want to do a repeater with that, whoever owns the repeater has to buy their equipment with their protocols and interact with their proprietary software. And it just didn't take off very much. I don't know all the reasons in history, but one that has taken off is called D-Star, and that one is sponsored or proprietary through ICOM. And it's called a codec that they use to encode the audio video. This one is an ICOM radio. So this is what we call a mobile unit that you can fit like in your car. So your unit doesn't have to be any bigger than the handheld I showed you or something like this. So it doesn't have to be like that big rack that I just showed you in the picture. But this one comes with your base unit, and then it also has a microphone like that, which has all the controls on it. You can pretty much do everything from the microphone, so you can mount this under your dash and just do this. Some of the newer ones have what they call a head, detachable head, so the faceplate will come off, and then you can mount it somewhere else. Back in the old days before cars got really complex with all the computer stuff in the center console, you would just drill holes and start mounting stuff. But since those days are kind of gone, you mount them to like a vent bracket or something, or maybe like a dashboard suction cup mount, which I don't like as well, just because they can wear out over a year or two. But anyway, there's options for mounting. I won't go into that too much. But and we're also going to cover power supplies. So that handheld that I showed you, it's designed for 12 volts. And you can get what's called a transformer. We're going to go over these, or not a transformer, power supply. Anyway, we'll go over that in a minute. I'll get the better words for it. But it's just a simple power supply. You plug in AC, and then you've got a switch on the front that turns it on. And then on the back, you just have two little places where you connect the red for the positive and the black for the negative. This particular one is a 13.8 volt. And then you have your AC plug that goes in there. So this is the same kind of plug that you might find on the back of a desktop computer, that same format. Anyway, so we'll cover that a little bit later in the chapter. So let's just start off with 5.1, modulation. Okay, so modulation, and we kind of covered this a little bit last time. If you guys, any of you who might remember the olden days where before we had dial-up. Well, we had dial-up before we had like DSL or fiber or cable or satellite, and you had to dial up, and it was audible. So you dial through the phone, and you had a modem. Mode is modulate, and dem is demodulate. So it was a modulator-demodulator, which means you take an audio signal, like your voice, and you transfer it into electronic signals, digital, and then at the other end you take the digital and transmit it back into audio. So that's kind of how you do it with AM or FM radio. It modulates and demodulates, and we're going to talk a little bit about that. So there's a couple of ways you can transmit a signal or a frequency. You can modulate. Well, let me just start off with bandwidth. So it's become kind of common term, and since I'm a software engineer, we use the term bandwidth a lot. Like, oh, I can help you later. I don't have the bandwidth for that. It means you don't really have the ability to take on all these things. Like you have a little bit of time to help, but not 2 or 3 times help. And so you might say, I don't have bandwidth. Well, what bandwidth is it comes from a frequency. So let's see. Signal can have both a frequency and a strength or amplitude. So a frequency is how fast the wave goes up and down. It might go slow or it might go fast. That's the frequency. And then the amplitude is it might go up a little bit or a lot or a little bit. So the amplitude is how far up the wave goes when it's oscillating. So the range is the signal's bandwidth. Your voice is made up of different frequencies, from 300 hertz to 3000 hertz or 3 kilohertz. So the bandwidth between the beginning and the end of the frequencies is 2700. So you just take 3000 minus 300, that's 27 hertz. So when I'm talking, there's 2700 hertz worth of data that you can get in my voice. And so, for example, MP3, when they came out with MP3, the Fraunhofer encoder algorithm, where they took the audio signals from music and compressed it, MP3 was one of the first ones that really took off. They found that the human ear didn't have the bandwidth to hear the upper and the lower frequencies in a lot of music, and they're like, well, let's just get rid of that and we can save a lot of space. So that's one of the reasons MP3 was able to do smaller compression in addition to whatever math they did to figure that out. I think it was a German, and it was called the Fraunhofer algorithm. But anyway, so bandwidth, we'll talk about bandwidth and why that's important in a minute. But so on 5-2, they've got some pictures and some diagrams and some examples of this. Okay, so let's just say for AM radio. So most people are familiar with AM and FM. A lot of people now don't even tune into live music, live radio like that. They'll do satellite or podcasts or stream or whatever through their phone. But most cars still have AM, FM radio, so hopefully most people are familiar with that. But let's say you're tuning into, let's see if they give an example here, an AM station playing music, frequencies between 870 and 890. So the bandwidth of that signal is 20 kilohertz. You take 890 minus 870, and that's 20 kilohertz of bandwidth. And so that's how much space that music takes up in the frequency bandwidth. And so if I were to transmit on, say, 875, I would be overlapping the other station that would be between 890 and 870. So you want to have spacing between stations when you transmit. So they do have separation, and we'll go over band plans later in another chapter. But we have mandatory per FCC laws about where you can transmit and what bandwidth and what modes. And we also have band plans. Within those specified ranges, it's voluntary about how you use those, for example, repeater frequencies, and it requires some coordination. So when you transmit speech to signal and back, the signal of a voice is called phone mode or voice mode. And then there's data mode, digital mode. So like data, think of like your text messages, or you pick up your phone and you so you get data on your phone, and all that data that you browse the web with or get data through. I think it's usually like, I want to say 800, 900 megahertz frequencies that are UHF is what a lot of cell phone towers and receivers run on. So you're doing data every day. You're doing data mode through the airwaves when you use your cell phone. Wi-Fi, same thing. It's 802.11 IEEE spec, and it is 2.4 gigahertz, 5 gigahertz are the common ones. That's the UHF frequencies. So you're doing data when you do Wi-Fi as well. So you got phone or voice, you have data. Those are 2 modes. Then there's analog modes that can be directly understood by a human. And the oldest one is Morse code. So those are just a series of dots and dits, long and short tones. So you take a tone like, and then you decide how long the tone is. That's dits and dots. And so based on that, you interpret that as a letter, and then you can spell out words or codes for transmitting information. And that's what people did back in the olden days with the telegraphs. All right, so in the middle of 5.2, it says there's 3 characteristics of a signal that can be modulated. First is the strength. So if you talk really loud, the strength is going to come out a little more of the sound. Frequency, like you might talk really high or you might talk really low. So those are the modulation of your voice. And then the phase, which is kind of like the dits and dots, like how when you start and stop the wave. Okay, so those are the 3 ways you can modulate. So phase modulation is known as PM, FM is frequency modulation, and then amplitude modulation is AM. So when you think about AM radio, it's using amplitude modulation, FM radio uses frequency modulation. And they both have pros and cons, okay? So CW, continuous wave, is also what is Morse code. So you take a continuous wave, like on the top, and you modulate it, you add in the voice, or you start and stop it, and you can create dots and dashes, as I said on that. Now, over on 5.3, this describes a little bit more. Figure 5.2, right here, you've got a center carrier wave, and then you have a left and a right side. So the left side is known as the lower sideband, and the right side is known as the upper sideband. And so you have 2 sidebands. So you have your carrier wave in the middle, and then you have voice on the left and on the right. So that takes up bandwidth or space on the airwaves. And so here's an example here on 5.2. It says an 8 kilohertz AM signal. So you notice here, if I'm listening to 800 AM, you're actually listening on 797 to 797.7 on the lower sideband, and you're listening to 800.3 to 803 on the upper sideband with a little space in the middle for the carrier. So you have about, what is that, about 6.6 kilohertz for the carrier wave in the middle, and you have voice on the left and the right. So you might take something like the left and the right, the upper and the lower, you might do, well, for FM, it would be like left audio and right audio, so you have left and right speakers, so you can do stereo, FM stereo. But that's not really how AM works, but you get the point. You can have 2 different data on either side. All right, so how do they say it? An AM transmitter adds to your voice an unmodulated signal varying its amplitude. So you notice on the upper and lower sidebands, you've got these high and low peaks. So that's the modulation up and down. That's the amplitude modulation, and it converts it to do speech. So taking speech or music from the envelope of an AM signal is called detection. All right. All right. So if you suppress one of the sidebands on figure 5.3, they have it kind of dashed or dotted. If you were to get rid of that lower sideband, that would be the upper sideband only. Then you can use less bandwidth, and also you can send stuff a little bit stronger signal, and so it allows the signal to be more concentrated. So if you suppress the lower or the upper and remove it, it's called single sideband, SSB. So when you see abbreviation SSB, that means single sideband. So the question is, which of the following is a form of amplitude modulation, T801, and AM is the answer. AM is one way that you modulate, is a form of that. So when you suppress one side. Okay. So on figure 5.4 at the top of the next page on 5.4, you've got another example here of the wave. You take a carrier wave over here, you add your carrier to the steady thing and the voice, and it ends up modulating it, and that comes out as your voice or the music or whatever it is. So, all right. So I'm going to go over some of these questions and just give you the answers. They're in 5.4, but one of them is T802. It says, what type of modulation is commonly used for VHF packet radio transmissions? So packet radio, FM, is the type of modulation. What type of modulation is commonly used for VHF and UHF voice repeaters, and that's also FM. So, go ahead. Do you have a question? No? Okay. So FM, one of the advantages to FM is the signal is very clear. There's less static. It's just has higher fidelity. You can also do stereo like left and right. So whereas AM is not as good as quality of the sound. So repeaters for VHF and UHF, they use FM mode. What is a disadvantage of FM compared with single sideband? Well, they give you the answer down there in the paragraph, but only the strongest signal can be received. So if you might have 2 or 3 signals on FM, and this receiver has to choose one, and it will only choose the strongest one. And a lot of things now have like chips in them where it tries to do error correction and enhance the signal. So it will only pick up the highest one. So that's a disadvantage of that. But FM rejects noise, so it is a clearer signal, better fidelity, you might say. All right, so the next question. T803 down below on 5.5-4, it says, what type of voice mode is often used for long distance contacts on VHF and UHF? So long distance contacts or weak signals, and they use SSB or single sideband because it requires less bandwidth and you can transmit it really strongly. So there's one of the things they use it for is what's called EME, Earth, Moon, Earth. So you send a signal from the Earth to the Moon and you bounce it back to the Earth. So Earth, Moon, and back to Earth. And you use the Moon as a natural satellite. And they will use SSB, single sideband, CW, carrier wave mode as Morse code to use the Moon as a satellite. And they can actually do it. And they can even take a meteor as it's coming in from the Earth, and they can aim your signal and use the meteor trail, ionized gas, as a mirror and bounce it off of the meteor trail, and you can actually communicate through the meteor using that as a satellite. So it's called scatter, meteor scatter, and I've never done it, but apparently you can do it. I don't know if it's like a few minutes worth or what, but apparently you can do that. And there's test questions on that later. But that's all you gotta know, though. Basically, meteor scatter, Earth, Moon, Earth, or any kind of weak signal, they will use SSB, single sideband. Which sideband is normally used for 10 meter HF, VHF, and UHF single sideband? So there's the upper and the lower, and by convention they use the upper for those bands for the 10 meter, the HF, the high frequency, the very high frequency, and the UHF. Let's see. What is a characteristic of single sideband compared to FM? So a single sideband, like I said, it's more powerful, so you can go further and propagate through noise. So if you have a lot of noise, SSB upper sideband is a good way to communicate, and it's also narrow in bandwidth, so it doesn't require as much frequency spectrum. So that's another advantage to that. Okay, and that's why, another term is DX. DX stands for long distance, and they call them DXers. So people are trying to communicate over long distance. We'll use these modes, like I mentioned, to the moon and back, right? Like Buzz Lightyear, to the moon and back, to infinity and beyond, right? So if you're trying to go a long ways, you want to use SSB. So DXer is the practice of making long distance contacts directly without any kind of intermediary, like without using a repeater or without using something like that. So there's different types of signals on 5-5. They have signal bandwidths that are listed. Okay, I'm going to do one for the webcam and one for the other cam. So there you can see up here. All right, so for those particular signals, CW or carrier wave Morse code has a little bit bandwidth. It doesn't require very much. And so if you just have a little bit of bandwidth to use, CW is the way to go. It's 0.15 kilohertz or 150 hertz. So single sideband digital requires a little bit more. It can go from 500 to 3000 hertz, or 0.5 to 3 kilohertz. SSB voice, 2 to 3 kilohertz. And then when you go up into AM voice and FM broadcast and video, it takes more and more bandwidth requirements. So, for example, VHF, UHF voice repeaters are approximately 15 kilohertz of bandwidth. So a lot of, in the band plan of the state that I'm in Utah, they try to separate those channels by 0.25 or 20, 25 kilohertz. They don't like to get them too close, because we'll talk about this in a little bit later, but if you broadcast and your voice is really loud or your transmission isn't that great, you can actually bleed or splatter over into adjacent frequencies. So they like to leave a little bit of wiggle room, you might say, between channels. And so even though it might only take 10 to 15 kilohertz, they might separate by 20 or 25 kilohertz when they're allocating channels, just so it doesn't interfere. So as a general rule in 5.5, it says below, in the middle of the page, below 10 megahertz, lower sideband is used, LSB, and above 10 megahertz, upper sideband is used. So if you just remember 10, upper is above 10 and lower is below 10. That's just by convention. There are a couple of exceptions. It says amateurs are required to use upper sideband on the 5 channels of the 60 meter band, 5 megahertz. So they do have certain exceptions to that on the 60 meter band, which is a lower frequency, so you can go longer. They're required to use the upper sideband, but all the rest of the bandwidths of the band plans and the frequencies, it's the lower one. All right, so the next thing, we're going to talk about transmitters and receivers, 5-2. Okay, so I'm going to just illustrate this with my radio. So on here, on most radios, you'll see what's called either V or VFO. On my particular keypad, it's just V/M. But VFO, I think there's a test question on it. VFO means variable frequency oscillator. So you start with like 2,000 and you increase more to 5,000 and you're varying the frequency. So when you dial on mine, I'll just turn it on, and right now it'll enter like the memory mode, and I can rotate between different memory channels. If I hit the VM, and then I tune my radio, I'm actually just oscillating the frequency. I'm increasing or decreasing the frequency. And so this little knob is adjusting it, but it's doing it digitally. Back in the olden days, they used to actually have it was called a variable potentiometer, just like a volume control, and they would use that to increase or decrease the frequency. Now they do it digitally, and you have a digital display. So VFO is a variable frequency oscillator. It's the way you select the frequency you're tuning into. Think of it as your tuner on your FM radio station or AM. So the question is, which of the following can be used to enter a transceiver's operating frequency? You can either use the VFO or the dial, or you can just type it in directly. So in mine, it's got like just numbers, and you just type in the frequency you want and hit enter, and it will automatically go to that frequency instead of having to like rotate through hundreds of frequencies. This one's a pretty easy one. What is a way to enable quick access to favorite frequency or channels? Well, it's memory channels. So like I said, this has 2 modes. It has a VFO mode where you directly enter. If you hit it again, it goes into the frequency mode. So there's a memory channel I picked up, and there's somebody having a conversation right now. A conversation in Q codes is known as QSO. QSO means conversation. So you might hear people say, oh, thanks for the QSO, thanks for the conversation at the end of your conversation. And another jargon they say, and I think this comes from the telegraph days. I don't know where they get all these different jargons, but one of them was the telegraph operators used to sign off by saying 73, and that meant goodbye. So a lot of people say 73s at the end of their conversation. You're like, 73s, what does that mean? Instead of just saying goodbye, because they used to repeat it, 73, 73. So they say 73s, goodbye, goodbye. And so anyway, so memory channels are really good because I don't think I've talked about it yet in my classes, but there's really, for basic operation, for AM, VHF, and UHF, repeater operation, you need to know 3 things. The frequency, the receive frequency, the offset, and what's called the PL tone. The PL tone is a subaudible tone. So when you transmit at the frequency, let's say you were transmitting, the receive frequency was 174.6. So you dial 174.6, that's the frequency that the repeater is transmitting to you at. You're listening on that one. Think of it as your earphone on a phone, and the speaker or microphone would be an offset of negative, which means you subtract, and by convention is 600.6.600 on the VHF band, so you would be listening on 174. So you listen on a lower frequency and you transmit on a lower frequency, your microphone, and you listen on, or receive on a higher frequency. So you listen on 174.6 and you transmit on 174.0. So you just need to know the receive, where to start, what the offset is, negative, and by convention, you know what your radio will automatically know. And then the third thing is the PL tone. So if I just start transmitting to a repeater that has a PL tone enabled, it won't pick your signal up. It wants you to transmit a special code, which is a signal, at the same time as you hit the button. And so the reason they do that is to prevent interference. So let's say you had a repeater over here and one over here, and they're on the same frequency, and somebody over here is trying to talk to this one, and somebody on this side is trying to talk to that one, and you might get a little bit of interference between them. And so what they do is they might have this one is on PL tone 123, and this one might be on PL tone 100. And that way this one won't retransmit signals from the guy on the other side, because he's using a different code. And so it's to prevent static and retransmitting of spurious signals that you don't want to pick up. So if you know that the PL tone, the offset, and the frequency, those are the three things you need for your memory. For convenience, I like to put in a call sign. I like to put in the call sign of the repeater. Every repeater has a call sign. They have what are called club call signs. So for example, here in our area, there's a club called K7 UVA, Utah Valley Amateur Radio or something. And they have K7 UVA for multiple repeaters. They might have a VHF and a UHF, and they might both use the same call sign. But so what I'll do in my memory is I'll put K7 UVA/1, K7 UVA/2, so I know it's like the UHF or the VHF repeater, just for my own sake. But I put the call sign in, and then the number, like channel number 20 or channel 30 or whatever channel you want to put it at. So memory channels are really good. And that's just for basic repeater operation. You can do the same thing for digital modes. You might program a memory channel to do digital only or certain other settings. That was a little bit longer on that section, but I wanted to go over that because that's really important. Because once you get your license, that's probably one of the first things you're going to want to do is hook up to repeater so you can extend your range. All right, so 5-6. We're going to go over that. So over here, they've got a couple examples of, these are HF probably, rigs or units. And then they also have a table on the left here of the band plan. It's not the band plan, it's the, well, they call it band selection labels. So it's the frequency on the left and the wavelength on the right. So these are kind of used, these terms are used interchangeably a lot of times. You might hear people say, I'm going to go on the VHF, which might be 174 or 144 to 148. They may say, I'm going to the VHF, or they might say, I'm going to the 2 meter. 2 meter is how long the wavelength is. They might say, I got a 2 meter rig or unit. I have a 2 meter HDX. This one does 2 meter and 70 centimeter, which is UHF. So that 70 centimeter is the wavelength. So they might refer to it as the wavelength, or they might give you the band. But because the bands, like the VHF, there's a 6 meter frequency, there's a 2 meter, and a 1.25. So you just kind of have to memorize these or know the frequency formula, which I think is like F frequency equals C, speed of light, divided by lambda, the wavelength, if I remember right. Looking in the chapter of my earlier video. But you can, those test questions are, we've went over those already. But I just kind of memorize them. I know that 50 megahertz on VHF, 144 and 222 is VHF, and I know that the 440 and my frequency on my radio is the UHF, and so it's also known as 70 centimeter. So you don't get much privileges in the HF and MF. You don't get any voice privileges, I should say. I think you can do Morse code and stuff on those with the technician license. But if you want to actually talk to people, you're going to need to get the general license, which is a level up from what we're teaching. So I started at my technician. One day I plan to get my general, but we're only covering the technician. But it is important to know that there are other bands you can have access to if you want to pursue further interests. All right, so okay, so this particular one is called a dual band radio. It does UHF, VHF, like I said, and the mobile ones can be single, can be just VHF, or it can be VHF, UHF. All right, so I'm going to talk about some of the modes. I've already kind of mentioned these at the bottom of 5-6. There's some of these modes listed. So some of the modes is SSB, single sideband, either upper or lower, that's voice, AM, FM, and there's CW or Morse code, that's a mode. We have data. So those are different modes. So on the radio, there might be a mode button. So on mine, I'm going to go to, I go to the frequency, and then there's a mode button here. And each time I push it, you'll see it go. Right now, it says, probably can't see it very good, but it says FM. As soon as I push the mode, it'll go to the next one. So now it says DN for, like, it's the data mode, digital mode. And I push it again. Yeah, this one's only going between FM and DN, data mode and FM. But it's also smart enough to know based on the band or the frequency I'm in. So if I push the band button, it'll switch to a different bandwidth, the band frequency spectrum. So I'm going to switch it to, so notice it says 108. That's actually the aircraft band. So the aircraft band, you can't really see it very good, but right here it says AM. So it automatically switched to AM because all the aircraft traffic and the pilots and everything, the control towers, they all use AM. So when you're listening to the air traffic, it'll automatically switch to the AM mode. But when I go to VHF mode, upper frequencies, it'll switch to FM mode. So modes are important, bands are important when you're trying to listen and program and use your radio. All right. Now we're going to go into transmitter functions on 5.7. Okay. So there's 4 questions there, and they've got some examples. The first one is, what is an electronic keyer? So a keyer is like your Morse code tap. That's just a little thing that you use to generate Morse code. So I happen to have, I recommend this company. I don't get any sponsorship, but I just want to mention them because I've used them. I just like them. Ham Radio Outlet. You can buy stuff anywhere. You can buy them at swap meets used online, but I like them if you're buying new equipment. This is one of their catalogs, and I'm going to use this as a visual aid because they have a lot of pictures of what these things are, better than the black and white pictures that are in the book. So a keyer, let's see if I can find it. Okay, so this one, here's some examples of keyers for Morse code. And yes, people still use Morse code, and they get real fancy into it. And they have gold-plated connections to like good circuit connections and stuff. And it's just funny reading the descriptions. Funny to me because I don't really do Morse code. If I'm really into it, it probably wouldn't be funny. I'd be like, yeah, this is really great. But there's 2 types of Morse code keyers. There's your standard one, like this one here. And then there's what's called a paddle. Let's see, or iambic. So this one here, there's 2 little knobs. You squeeze the left or the right. The left is the da, and the right is the da, 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 da. So if you just push the right and hold it, it'll just go da, 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 and when you let go, it stops. And the left one, it goes until you let go. So all you do is you're just alternating between dits and das, and you're just touching and letting go of the left and the right paddles. They say you can generate Morse code quicker that way. I don't know because I haven't done Morse code. Or you can just tap it and try to do it manually. So the advantage to an electronic keyer, what is an electronic keyer? Electronic keyer is the paddle that I just mentioned. And what it does is it has a little electronic circuit in there that times the length of the dits and the das. So I will put a quick 5-minute YouTube video that I saw this last week that's pretty good explaining this. And I'll link it here in the video later. But basically, the dits are supposed to be 1 unit of time, like dit, and the das are supposed to be 3 times longer than the dits. Da, dit, 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 and they're supposed to be a 1 unit length, just a pause between them. So, and then there's supposed to be like 5 units of time between words. And so you can try to do that on your own, like trying to figure out the timing of dit, dit, dot, dot, dot. Or you can just push the button and let the computer generate the right length for you, or the electronic circuit. So an electronic keyer automatically generates those dits and das. That's kind of the answer for that question. What is the function of a transceiver's PTT input? Okay, so in this example, this is my mobile unit, and it's got a little button here, and it will be labeled PTT. It stands for push to talk, PTT. So the function of that is to transmit. Very simple. And my handheld, same thing. It's got a little button right here. When I push it right now, I'm on the AM mode on the aircraft, and since this radio doesn't transmit to the airplanes, you don't want it to, it'll just give you an error. But when I push it, you can see it would do that. So if I were to switch to another band that I have access to, this is just simplex, and I just push it, it'll transmit and light up. And so so the PTT is just to transmit. That's the answer, push to talk. That's what its function is for. Real simple. Okay, the next thing is a dummy load. Okay, so if I were to hook up my radio like this, and here's my antenna, and I power it up and I push the talk, I'm going to generate power out of this, and it's going to have nowhere to go, and it might actually fry your circuits from what I understand. There might be electronics to stop that, but you don't necessarily want to hook up your antenna and just start transmitting when you're trying to test things out. If you really don't have a conversation, you don't want to sit there and identify when you're trying to tune your radio and get your right length of your antenna. So they use what are called a dummy load. You hook this up, and there's what's called a balun, or balun, I think is what it's called. And it's just a big high capacitor that absorbs the energy that your signal is putting out. So all it does is it's just a drain place for the energy to go, and it just heats it up. And so the purpose of a dummy load is to just absorb the energy, and for testing and tuning and that sort of thing. And so what does a dummy load consist of? It's just a big resistor. So that's it. Let's see. Oh, also when you're transmitting, there's different power settings. Okay. So mine, it has a key called TXPO, which is transmit power. So I hit function and TXPO, and that will adjust the transmit power. And most radios will have 3 settings at least: low, medium, high. Sometimes, like my ICOM here that I just showed you, the mobile one, it has 4 settings. It has low, medium, high, and then high. So they have 4. So the general rule is, it's kind of like when you're talking in a crowd of people. You want to use the lowest voice it takes to get your message across. You don't want to shout when you're right next to someone, right? So you don't want to use 100 watts of power when you're trying to talk to somebody through a repeater that's a couple miles away. You want to use the lowest power necessary. So handheld like this, the high power on this one is 5 watts. It might be 1 watt, 2 watt, 5 watt. So if I can hit the repeater with 1 watt or half a watt, I would just set it on low and use that, because then I'm going to not interfere with other people, and also you save your battery, But if you're a long distance away and you're having trouble hitting it, you might have to go to 5 and turn it up high. So there's power settings. On 5-6, they have actual knobs. On these others, so they can be a knob, or they can be most of them now are just electronic. You just push a button and it adjusts it.